Hi everyone and welcome to today's Physics Daily Booster. This is number 19 and the final one in the Paper 1 series. What we're going to be doing today is GCSE Physics higher tier only content once more because that's all the end of this paper actually is. What we're going to start off with then is the idea of transformers. Now when we talk transformers, we're not talking about robots that can change into cars and vice versa. We are talking about a device that's used to either increase or decrease the potential difference. Now hopefully we do remember that we can induce a potential difference when magnetic field lines cutting a coil are changed. So what we're going to find is there are three ways that we can change the field lines cutting a coil. First, move the magnet or move the coil. Secondly, use another coil and turn that current on or off in that. Or thirdly, we can use another coil with an alternating current. So three ways that we can then change the field lines cutting a coil. Move the magnet or the coil, use another coil and turn the current on or off, or use another coil with an alternating current. Hopefully we remember from our previous booster that when a current flows, it produces a magnetic field. Now, if we just have a coil and we turn it on and off repeatedly, then we're changing the number of field lines cutting that second coil. Because obviously we're turning on field lines and therefore there's more to cut when it's on, and then when we turn it off, there's less field lines because there is no magnetic field. So we're changing the number of field lines being cut in that second coil. If we use an alternating current, AC, then the field lines are going to constantly change because remember what we said, the current is going to be constantly changing from positive to negative. So we're constantly changing the direction of our current in that alternating current, therefore we are changing the field lines being cut. So what is a transformer then? Well, basically it is a core of iron in this loop shape, and we have two coils, one on the left, one on the right of it. The reason that we have this loop of a magnetic material, i.e. iron, is because the magnetic field then becomes trapped inside that iron core. What we're going to do then is we start off with our primary coil, which in this one is the red one on the left hand side there. So we have our primary coil, and an alternating potential difference across that primary coil produces an alternating current in it. So we have an alternating current in that red wire there. As a result, what we're going to do is produce a magnetic field in this iron core that is constantly changing. So as the current alternates between those two sides, then the magnetic field is going to switch. As a result of that, what we find is in our secondary coil, the blue one on the right, we're going to induce a changing potential difference because that wire there is going to be cutting a different number of those magnetic field lines. Therefore, it's going to induce a potential difference. That then allows a current to flow in the secondary coil. We have two types of transformer we need to know about, and if you remember nothing else about transformers, this is the bit to remember. Step up transformers increase potential difference, and they will always have more coils on the secondary compared to the primary. So this one here on the left, that is a step up transformer because there are more coils on the secondary coil compared to the primary. That's going to increase potential difference. Option number two, the step down transformer, the one on the right here, this one decreases potential difference because it's got more turns on the primary coil compared to the secondary coil. The next device we're going to look at then are microphones. We need to know how a couple of types of microphones work, and we're going to start off with the dynamic microphone. Now this one works quite like a generator in reality. Hopefully we recall from earlier work that sound waves are pressure waves, so that what we can see on the little diagram on the right here is our sound wave comes in, the pressure wave, and as it hits the diaphragm, which is this little bit along the front here, then what it's going to do is push it in on those compressions, the area of high pressure. Where we've got an area of low pressure called a rarefaction, it pulls it back out. Now notice that the diaphragm itself is resting against the coil which sits over a magnet. So what's going to happen is, as the diaphragm moves in and out, the coil also moves in and out. As a result of that, it's going to be passing over the magnet, therefore cutting field lines, induces a potential difference across the ends of the wire, and therefore we create an electrical signal. That then gets fed into whatever device is going to interpret that. Second type of microphone is a carbon microphone, and this one just has little granules of carbon behind the diaphragm, so that as that sound wave hits the diaphragm, changes the resistance of the carbon, and therefore the current passing through those carbon granules changes because the resistance also changes. So there are two types of microphone. Dynamic microphone, I would say, is more likely to come up than the carbon one, but just remember, carbon is to do with resistance changes. The dynamic microphone, we're inducing that potential difference again. Final device that we need to know about is the loudspeaker. Now, loudspeakers behave a bit more like a motor. If we're trying to think of what the loudspeaker actually is, we look at our diagram down here. We've got a diaphragm, we have a coil, we have a magnet again. Same kind of bits that we've just seen. Now, what's going to happen is, if we connect the ends of the wire to a changing potential difference, we're going to hear a sound. Reason? Because that changing potential difference produces a changing current. That is going to produce a force on that coil of wire, because where it's sitting across a magnet, it's in a magnetic field. And therefore, depending on the direction of that current, it's going to make the cone either move in or out. As it moves in or out, it's going to push against the diaphragm. That's then going to generate those little pressure waves, which is our sound wave. Because as it moves out, it's going to cause compressions. As it moves in, it's going to cause rarefactions. Obviously, the movement of that coil is going to depend on the size of the potential difference. So this is the final daily booster for the paper 1, and I know what you're thinking, this is quite a while before our paper 1 exam. Yes, it is, but that's only because in order to fit in all of the daily boosters for paper 2, we need to start a bit early. So we're going to start going over some of the paper 2 stuff as of tomorrow in our daily boosters. We will still have our live stream for paper 1, that will be on Wednesday the 8th of June at 6 PM. But as I say, we've got to do some of the paper 2 daily boosters before paper 1, otherwise we just won't fit them in, or they'd be about kind of 30 minutes long a piece, and no one wants to listen to the physics for 30 minutes after you've potentially done exams. I understand that. So if there are bits from today's booster that you wish to go over in more detail, there's the video on the main channel, you've got your revision guides, and as always, have a look at least a couple of paper 1 physics before you actually sit this exam paper. Don't forget to join us for the daily booster tomorrow, and of course don't forget the live stream for paper 1 physics, 8th of June, 6 PM.